We're going to do an example of finding the distance between a point and a line. In this particular case, we have a point here that's given, and we have a line that's given. So something that might be helpful is to construct a diagram of what that looks like, and then we can build the pieces from the algorithm. So I have some sort of line, and I have some sort of point in space. So Q, and then this line is described by this set of equations. So we need to find a point P on the line, and we need to determine the direction vector V for the line. Well, if you remember, the direction vector is the coefficients on this T. So it's the coefficients here. And since x didn't have anything, I went ahead and added that 0, and I was explicit about that 1. So that tells me that V is 0, 3, 1. And remember that the distance is the magnitude of the directed line segment PQ cross V. It's the magnitude of that vector over the magnitude of V itself. But we still don't have P. Well, an easy way to get P is to set the value of T to be 0. So if I set T equal to 0, I get that P is 3, 1, 1. So then we can get PQ by taking P and Q here. So we have a vector of 1, looks like -2, and looks like 4. But then we need to get PQ cross V. So to do that, we have to be write a little bit more. And V is so let's go down the line here. -2I plus 0J plus 3K plus 0K minus 12I minus 1J. So that gives us -14I minus J plus 3K. And now you might want to make sure that it is orthogonal to PQ or orthogonal to V. So if I take this here and I dot it with V, I get 0, -3, +3. So that adds to 0. So we can feel reasonably confident that we've computed the cross product correctly. So again, that's PQ cross V. But we need the magnitude of PQ cross V. So that's -14 squared plus -1 squared plus 3 squared, which is 196 plus 1 plus 9, which is the square root of 206, which may reduce, but I can't think of it off the top of my head. And then we have the magnitude of V, which is the square root of 0 squared plus 3 squared plus 1 squared, which is the square root of 10. That's simple enough. So that tells me that my final answer, PQ cross V over the magnitude of V, is square root 206 over square root of 10, which I'm going to reduce to 103 over 5. And that's how we get the distance between a point and a line.